So, Bismillahirrahmanirrahim. So, let us start our module 8. And in this module, we will be designing the columns as per the ACI code, and we will design our beams as per the code. So, for the design of the columns, the longitudinal reinforcements has limitation, and that is 1% to 6% of the gross cross-sectional area of the columns as per the ACI 318-14 section 18.7.4 for the special moment resisting frame systems. And this is the section which explains the आज मैं थोड़ा सा गला भी खराब है. So this is the section which is the 18.7.4 that the area of longitudinal reinforcement AST shall be at least 1, which is 0.01 AG, which is 1%, and shall not exceed 0.06 AG, which is 6%. And for the normal RC columns, the limitation is 1 to 8%, which we have discussed it in our previous modules. The next step is that you can design your columns as per the architecture. For example, the architect have given the column size 24 cross 24, and then you have to check that whether it is working or not. If it is working, that's fine. If it is not, then you can change the size. So for the economy purpose, you can change the size of the columns as you go up in the stories. For example, if it is 10 story, so you can reduce the column size from 24 cross 24 to 18 cross 18 in 4 stories, 3 stories, and 5 stories. You have to check that with the trial and error method, that first you have to assign the section of 18 cross 18 in the 5 stories, then 4 stories, then and if the columns are passing and there is no issue, you can use that. So we will define a new section for the columns for just for the economy purpose. We will take copy of this and we will name it as C18 cross 18, and we will change the dimensions, and everything will be remain the same. We click OK, and if we check the number of stories, because these 2 stories are for the Momties and for the Overhead tank 12 and 11 and 12, and these are the 10 stories, and we will assign the 18 cross 18 column size to the beyond the 6 stories. We will assign it to story 7, 8, 9 and 10. In 4 stories, it means in 6 stories the column 24 cross 24 will work, and then in the 4 stories 18 cross 18 we will assign in our building. So let us turn off the beams, floors and walls and openings, and let us use this another command. Go to the modify shell, the similar story command. We will make it no all of these, and from the 7 stories we will make it as yes, because it will be acting as a master story. So, and we will assign all other stories. For example, story 8, we will link that story with the story 7. So whenever we are doing any changes or we want to select structure member, it will select in that story as well. For example, if you select the columns in story 7 with the similar story command is open, so it will select the columns or beams or slab in all the remaining stories that has been linked to story 7. So we will select the similar story, and for example we are at story 7, and let me select only one column. So on the left hand corner you can see it is selected 4 columns, 4 frames, right? This is because it has the similar story command. So now we will select all the columns. So it will select, let me go to 3D. You can see it has selected the columns and all the stories that has been linked with the story 7. If you can see in the elevation, you can see this is story 7 and it has selected the columns in the 8, 9, 10 and 12 and 11, all the stories. We will go to the assign frame section properties and we will assign C18 cross 18 and we click on apply. So now you will see that in the six stories, for example, this is 1, 2, 3, 4, 5, 6. In 6 stories, the column size is 24 cross 24, and in 1, 2, 3, 4, the major four stories that will have 18 plus 18. This is just for the to save the reinforcements and the concrete, just for the economy purpose. If you are willing to use this 24 24 from foundation to top, you can use it. So after that, you have to run the analysis. After you run the analysis, you have to go to the design, click on the concrete frame design, and from here you can see the code that you want to use. For example, the design code is ACI-318-14, and keep all the parameters as default. And after that, you can check the load combos that you have defined. For example, if they are not in here, so you can select and you can click that include in the design combos. If you want to delete a specific combo, you can delete exclude that from the design combination. And then you have to go again, and if this is not clickable, you have to click on the start design check. So the software will start the design because we haven't run the analysis. It will take time. I have already run the analysis, and you can go to the design, concrete frame design, and you can click on the start design slash check. If you click on this, software will start designing the structural members that consist of the beams and the columns. That is why I always use two models in which I can demonstrate, and the other I have already run the analysis of the design, so it can save time. You can see it is taking time, so let us wait. The next would be to find the amount of reinforcement. You will check that in the E tab as well when it finished the designing. First, you have to check the minimum reinforcement that the code says that you must provide. And for our column, the 24 plus 24, the minimum is 1%. And if you multiply 24 plus 24 with 0.01, the value comes out to be 5.76 inch square. And if you divide this with the area of the bar, number 6 bar, which is 0.44, so the required bars minimum is 13 number 6. Let me show you how we do that. For example, the area that we got from the this calculation is 5.76, and if you divide it with the area of number 6 bar, so it will give you 13 bars. So you have to provide 13 number 6 bar as a minimum reinforcement in 24 plus 24. Similarly, the same procedure can be followed for the 18 plus 18, and the minimum reinforcement is 3.24, and if you divide this with 0.44, it will give the value number of bars as 8, number 6 bar as minimum reinforcement. So let us do that again. This is 3.24 divided by 0.44. So these are 7 bars. You cannot provide 7 bars because it is a square column. You must give the even numbers, whether you have to give 4 or 6 or 4, 8, 12, 16, 20, 24, just like this. Let us go to the E tab. Let's go to the elevation. Let us turn off the beams. So these are the reinforcement. You can see the reinforcement. This is the longitudinal reinforcement shown by the E tab, and it is written in here. You can see the elevation view longitudinal reinforcement as per ACI 318-14. So it says that the 5.7 inch square, if you right click on this column, it gives you an information about the column specifically, and it will be highlighted like just like this. You can override if there is any change you want to do in this column. You can change that, and this is the interaction diagram. You can check whether what is the demand to capacity ratio for my column. This is for the all, and if you want to check it for a specific combo, for example combo 2, you can see that the demand to capacity ratio is 0.2. It means the 20% capacity of the column has been used, and it has 90% of capacity. The next one is summary, and this is the flexure detail, share, joint share, beam, column details, and this is the envelope. We will be interested in summary. And you can see that the code will appear in here that you have used. This is the column element details. It is a special. This is the load reduction factors, which is calculated as per the code. This is the length of the column. This is the section property you have assigned. These are the section properties, 24 plus 24. This is the cover. This is the DC, which is the cover to the center of the bar. This is the material property that has been used, FC prime, Fy. These are the design code strength reduction factors. And these are the axial forces and biaxial moments, PU, M2, and M3. And this is the reinforcement that is required for your column, that is 1%. It means that the column is working with the minimum, which is 1%, and they are the different factors, axial forces, biaxial factors. This is the shear. The shear reinforcement is zero because it requires zero shear reinforcement, because the shear capacity of the concrete is more than the demand. For example, this is the demand shear VU. This is the shear force demand on the column, and this is 5 VC, which is the shear capacity of concrete of the column, which is 66. So that's why the shear that will resist by the steel is zero. So that's why the rebar required in the column for the shear is zero. But we will provide the shear reinforcement uh, as per the code. And you can see this is the beam column capacity ratio, and it says at the major it is 0.079, at the minor it is 0.25. It is actually a check for the strong column and weak beam. If this ratio is greater than 1, it means that the beam is strong and column is weak, which is not good. We want our column to be strong, and we want our beam to be weaker than column. So this ratio should be less than 1. So Reinforcement required in the column is 1%. How we can check that? You can go to the concrete display design information, and there's a different the output and input information you can get. For example, the design input, you can check which section has been assigned. So you can check that this section has been assigned. You can check the design type. You can check the different factors, live load reduction factors that has been used in the design of the columns, right? And the design output, the first one is the longitudinal reinforcement, which is given by the E-tab as default when you click on the design. This one. The next, if you want to check it with the rebar percentage, you can check it that how much reinforcement in percent is given by the E tab. So we will use this command, and you can see it is 1% and it is 1.48%. This is 1.6. If you right click on this, go to the summary. You can check the rebar percentage required is 1.6 and the rebar area is 9.25. This is for the 24 class 24. Similarly, you will check all the columns in the elevation, you can check them in the 3D, and you will ensure that no column is red, because the red column is over stress, and then you have to change the FC prime, you can change the thickness of the columns. I am changing the elevations, you can see all of the 1%, and there must be some other percentages as well. You can see that it is 1.41% and 1.55%, 1.13. And remember that for the construction purpose, you have to select the maximum, or you have to give reinforcement in the column sizes the same, because you cannot give, for example, in this column it is 1.4, the other is 1.3, the other is 1, and then you will keep on increasing the number of columns. For example, 20, 25 number of columns C1 to C25, because the reinforcement is very different. One column the reinforcement is 12 number 6, in other is 10 number 6, the other is 15 number 6. You have to make it very easy for the field engineers as well. So the columns are passing on the minimum reinforcement, so we will provide 2% of the reinforcement, because the range is from 1% to 6%, and it is passing on the 1%, but we will provide 2%, because there is different factors in advanced level talking that I'm not going to explain. There are different factors, momentary distributions, and the live load patterns. And keeping in view these factors, you must give at least, for example, the reinforcement is 2%, you must provide 2.5%. If the reinforcement is 1%, you must provide 1.5 or 2% reinforcement in your columns. This is the simple formula. So if you provide 2% of reinforcement in your column, it comes out to be 16 number 8 bars. And how we do that? We will multiply 0.02 into 24 into 24. So this is the total rebar area required, and we will divide this rebar area with 0.8, which is the rebar area of number 8 bar, and it is 14.4. So we will provide 16 number 8 bars. Similarly, for the 18 plus 18, we will check the 2%. This is the rebar required, and we will, for example, if you want to use only number 8 bar, you have to provide 8 bars, and if you want to use number 6 bar, you have to provide 16 number 6 bars in 18 plus 18. But you have to keep in mind different factors, because later on we will move towards the shear shear reinforcement in the columns, that the number of bars should be enough to have the grip for the number of legs that you will be providing in your column. So if you check how much reinforcement I have provided in this 4 number 8 bars, for example, this is 4 into 0.8, and the next one is 8 number 4 bars, no, number 6 bars. So we will sum up these, and then we will divide this by the area of the column. So it is 0.2, which is 2% of reinforcement. So you can check the top story column as well, which is the 18 plus 18, and it has been designed for combo 9. We'll check the summary, and the column size is 18 cross 18, and the FC prime is 5000. I would recommend that you do not decrease the FC prime for the stories up to 10 stories or 13 or 14 stories. Keep it as the same. If the story is, for example, 20 story building, you can change the FC prime. For example, at the 10 stories, keep it as 6000, and for the remaining 10 story, keep it as 5000 and 4000, right? The next is to find the shear reinforcement in the columns, and we have checked that the shear reinforcement given by the E tab, some of the columns is 0, but we will check in different columns. What I have excluded from this model, that in the 24 plus 24, the maximum reinforcement required was 0.959 inch square per foot, and for the 18 plus 18 it was 0.68 inch square per foot. How you can check that? You will go again into the design output, and you will click on the shear reinforcing, click on apply. You can see that the reinforcement in here is 0, but in some of the columns it giving me some values. This is the 0 point, the two values shows the first one is for the minor and the second one is for the major axis. We will right click on this, we will go to the share, and you can see that the reinforcement for this one, combo 8 minor axis, this is the share. The reinforcement required is 0.25 inch square per foot. And I have added 0.59 because there is a one to three columns in which the reinforcement is very high, and we will apply that on the all columns. Because we want consistency in our design, we will keep on checking the different columns. You can see there is 0.7 as well. This is 0.62, and let me check the combo 5, 0.7. So the maximum is 0.7 in the column 24 cross 24. So we'll put that value in here, and let us do the calculations. For the 18 cross 18, it is 0.38, 0.47, it is 0.27, 0.63, 0.62, So you can see these are the different values. You have to select the maximum. This is 0.69 which I have taken. So this is okay. So this is the demand. Now you have to calculate the number of legs and the rebar size and the spacing. So the area of one leg, let me draw one thing. For example, this is your column, right? And you can see these are the different bars. So there is a ring, right? So in each direction, this leg of the ring, this is one leg, and this one is the second leg. So it is two leg in this direction. This is the one leg, and this is the second leg. So two legs in each direction. So if you provide cross ties, so it will become a third leg in one direction and third leg in another direction. Similarly, if you provide another leg, so it will be four legs, right? So we will be talking about the number of legs. For example, the area of one leg for number 3 bar is 0.11, and we will divide 0.7 by this. So how many legs we need? We need 6 legs if you use number 3 bar. So if you use number 2 bar, for example, the area of one leg for number 4 bar is 0.2. So we will need 3.5 legs. It means we will need 4 legs, right? So the area for the 4 legs is 4 into 0.2, which will become 0.8, and then you have to divide this area of the number of legs that you will provide by the area of reinforcement required, which is 0.7. So it is in feet. So multiply with 12. So you will need 4 legs, number 4 bar at the rate 13 inches center to center to resist the shear in the column. But we will provide 4 legs, number 4 bars at the rate 9 inches center to center. Right? The next is for the 18 class 18, which is the 0.68. The same procedure is followed, and it comes out to be 4 legs. This is 1 leg, 2 leg, 3 and 4. So 4 legs will be number 4 at the rate 6 inches center to center. And these are the limitation of the ACI is given on the 25.7.2. The declared spacing should be at least, this is the actual diameter of the aggregates. Center to center spacing should not exceed at least 16 dB of longitudinal bars, which is the 16 inches, which is we are use number 8 bars. And then the 48 tie bars of the tie bar is the smallest dimension of the member. Smallest dimension is 18 inches or 24 inches, and the 48 dia bar that for the use for the ties, it is 0.5 dia, and it comes out to be 24, and we have provided 9 inches and 6 inches. So there is also a limitation on the maximum spacing for the shear reinforcement in the columns, and it is defined in the table 10.7.6.5.2, and it says that the maximum S in inches, where Vs is the demand. This is the capacity of the concrete, shear capacity of the concrete, and if this Vs is less than or equal to this value, so you can follow for the non-pre-stress column D by 2 or 24 inches. or if this value is greater than capacity, you will use d by 4 or 12 inches. So normally, if you calculate the shear capacity of the column, it will always be greater uh, than the Vs. So these two will be, go on, let me show you. If you go to the plane, and so let us check, because the for the columns and for the beams, these are the same, but we will talk about this in the design of the beams. So we will go on this one, d by 2. D is actually the dimension of the column, which is 24 and 18, and it is 12 inches and 9 inches. 9 inches is the maximum spacing that you will provide, and next one is 24 inches, right? So the maximum limit is 9 inches. That was we have provided number 4 at the rate 9 inches into the center. You can also provide number, if you want to make it number 6, you can use number 3 bar in order to make it 6 inches center, or you can use combination. For example, the ring is number 4 and the cross tie is number 3, and you can do that, make it as number 6. But in our design, we will make it at 6 inches center to center. So I have written 9 inch center just to show you that there is a limitation on the maximum space. So here, this is the final output which we will update. This is the four legs number 4 at the rate 6 inch center, and the for the columns, this is remains the same, and this is the longitudinal bar, this is the ties, this is longitudinal bar, and these are the